All right, good morning, guys. This is Monday the 25th for KAP talking about circles today. Please start with completing this form up, pause, and play when you're ready. So we have a shape on this board. What kind of shape is it? Trapezoid. How do I know? Raise again. How do I know it's a trapezoid? One leg.
Four sides and there's only one set of parallel.
One set of parallel sides. There's another more obvious way to know that it's a trapezoid. Nathan? Not quite. Anyone see the very obvious way?
It has an acute angle.
Not quite. Nope.
There are two right angles.
Nope. 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 It says trapezoid. Okay, you laugh now, but you don't know how many times. Pause. Miss Lyle has given quizzes and tests, and people like put the wrong formula despite it saying this is a good shape, and people did the wrong thing. Okay, so. Yes, there was many other reasons, but obviously if it says it's a trapezoid, it's a trapezoid. Okay, so whenever we solve any sort of area problem, this Lytle always has 3 easy steps. So 3 easy steps are FSS, and FSS stands for? Awesome. So what is the formula for a trapezoid? A equals? Very good. So the two bases, what has to be true about the bases in a trapezoid? They have to be parallel. So in this case, are the top and bottom or the sides the bases? The sides are the bases. Does it matter which one is B1 and B2? No. Okay, so let's substitute 1/2. B1 and B2 would be 4 and 8. It doesn't matter if you switch it. My height. What has to be true about the height of any shape? Not straight. It has to be perpendicular to the bases. So perpendicular means what kind of angles? Right, or 90 degrees. So the 4, we have those little squares showing that 4 is the height. Okay, remember, natural pieces of paper can also rotate. Okay, 4 is perpendicular. 5 is a slant type. 5 is there to distract you. It's literally, it is important to know, like if you're finding perimeter or something like that, but in an area problem, useless. Cross out the distraction. Okay, I've done my formula, I substituted, now I need to solve. What's going to be important when I solve this problem? Yes, sir? Not first. You have to do that grouping first as an order of operations. Class 4 plus 8, 12. Remember, when you start solving, don't forget to rewrite that fraction. Now, I can do this in any order that I want to. Let's get rid of that fraction. Let's do 1/2 of 12. Well, let's get rid of the bigger numbers. That's going to give me 6. 6 times 4, 24. My units are meters squared. Boom, bam. Any questions? Okay. On the homework, were there any questions that I could go over? If only we did it in this class. Okay. Yes.
I did the homework.
Correct. Okay, yeah, and people in this class did it too. Just because you didn't doesn't mean that everyone. Thank you so much for your feedback, Tiff. I want to know if there's questions on the homework, not comments on about how much. So for today, for those of y'all watching online, we're probably going to include a YouTube video for this discovery part of the lesson. It's not going to be as easy for you to do at home. I will record each page and you can try and follow along. But again, there's this YouTube link in the course. So pause and play, read these instructions, but it's going to be hard for you to understand. All right, so the next page, again, pause and play for those of y'all at home. Okay, at class, I'm going to instruct them some more. All right, so for those of y'all at home, what you should discover, if you do this correctly, let me clear this off. You took a string that you were measuring across the circle, and you were supposed to see, okay, if I took that string and I started it here and I lined it up along the edge, you should get it like here, and then there's another like here, and then you end up having 1, 2, 3, and a little bit of that string. Okay, and we just talked about in my class how that 3 and a little bit number is high. 3, 4, 1, 4, 1, 5, 9, blah, 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 blah. Okay, today is that day that we're learning about high. So, did we all have different size shapes in my class? Yes, some of them were bigger, smaller, medium, all this kind of stuff. If you did this with the world's smallest, like if you tried to do the circle of a pencil, like the eraser of the pencil, you could probably do it, but like ain't nobody doing that in my class because that's too tiny and I have that patience or the time for y'all to do that because Love y'all. No. Not okay. But at home tonight, when you're bored and not doing your homework necessarily, you know, for our homework in this class, you could do it with a pencil too. Okay, but what we're going to learn about today is we're going to talk a little bit more about pi in different parts of the time. We're going to spend the rest of this week talking about circles. If you've already started your test review, you've hopefully noticed that there's some questions on circles. In my announcement said it's not due till Wednesday. That test review isn't due until Wednesday because we have circle stuff that people might not know yet. Okay, so we're going to first introduce different vocabulary for a circle. So please label these pieces with me. We are on the notes now. Okay, so the first thing that we measured in our circle was this distance across the circle, hopefully going through the center. We said to try our best to go through our center. That distance across is called the diameter. This is called the diameter. Again, that is the distance across going through the center. Let's go ahead and label the center. Okay, it's a very technical word, center. This is the center. Okay. That distance that Cobell just said from the center to the outside, that is called the radius. Okay? So, real quick, pausing and reflecting. What do you notice about the diameter and the radius? What's the relationship between those two? Maya, what do you notice? Radius is half the length of the diameter. Do y'all notice that? Okay, what's another way you could say that? Jason? Okay. Do you want to answer it or not? Okay, it's new. 2 radius, if that's a radius right here, and that's another radius, 2 radii is equal to a diameter. Do y'all see that? Okay. Now, to clear up any misconceptions, the diameter does not have to be horizontal. The diameter could be diagonal, to go from here through the center to the other side. Again, the only thing about the diameter, it has to go from one end through the center to the other. Okay? Same thing with the radius. The radius is just any point from the center to the edge. It's only half the length. Okay? Then, after we measured that distance across, we took that diameter and we measured that distance around. Okay? Normally, we call that the perimeter of the shape, but circles are special. They have their own word for perimeter. That word is circumference. The circumference is that distance around the circle. The circumference is that distance around the circle. So, in summary, when we took that circumference, we split it into the distances around. Mathematically, what we just did with our shape is we took the circumference and we divided it into however many diameters that would fit. When we did that division, we found out that there was 3.141, blah, 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 blah. It'd be 3 and a little bit times around. Are y'all good with that? Sort of, kind of. All right, so just going a little bit in this. Okay, so again, a circle, the definition of a circle is the set of all points in a plane that are the same distance from the center. The center, again, is another word for the middle. The point from which all points in the circle are the same distance is the very middle of the circle. There's circumference. We use the letter C for circumference. Is the distance around. It's just a fancy word for a circle's perimeter. Okay, remember, perimeters are on the rim. It's the edge of those shapes. Okay, the diameter is the distance across a circle, but it must go through the center. If it goes across but not through the center, there's a different word for that. You'll learn those words later, not important right now. A radius is the distance from the center to any point on the circle. And lastly, pi. Pi is a ratio. Ratio, how does Miss Otto always or often write a ratio? In what form? Fractions, usually a fraction. And we just said that the way that they get pi is they do the fraction or the ratio of
Circumference over diameter.
Circumference to diameter. Circumference to its diameter. We divide that circumference by the diameter, we get 3.14159. Okay? It is a ratio. That's a very important thing to remember. Does the order matter?
No.
Yes.
Yes.
Ratio. The orders always matter in a ratio. If I did diameter divided by the circumference, if I did that short distance divided by the long distance, am I going to get 3.14?
No.
No. Circumference to diameter. Okay? Last little bit, we already talked about this. To find the diameter, if I'm given the radius. If I'm trying to find the diameter, but I'm given the radius, we would need to multiply by 2. Volt by 2. Volt. I'm abbreviating.
Wow.
Wow. Okay, turning that into a math equation. D for diameter is equal to 2r. Other way around. If I'm given the diameter and I need to find the radius,
Divide by
divide by 2.
2.2.
Take the diameter over 2. You could also multiply by 1 half. 1 half. 1 half. 1 half. Thank you for serious answers. All right, y'all good?
Yep.
Next page.
What the?
Okay, thank you so much. All right, again, the pi is the circumference. My smart board is a little funny today, so that's our circumference. Divided by its. Oh, God, yeah. And that's how they got pi. Again, before there was technology, phones, TikTok, electronics, electricity, period. What people did for fun is they discovered things. Okay, one of those fun things that they discovered is any circumference divided by the diameter is always the same number. That same number is always pi.
You said divided by that number a bunch of times.
Huh?
They kept on zero and zero.
They like math.
How that was.
Thank you so much. Okay, so again, pi, that is how we spell pi. There's not the food, there's no E in it, it's just pi. Okay, there's the symbol pi. You can write it in different ways. I don't care, as long as there's 2 6 in a line. Okay, again, it's the ratio of what? It is the ratio of,
Circumference to diameter.
one more time, it's the ratio of,
Circumference to diameter.
okay, I think it's important. How many times have we written it already?
Twice.
3 times circumference. Okay, so let's talk about pi. Okay, this number right here are the first 100 digits of pi. Pi is a special number in that it doesn't end. There's more than 100 digits. There's millions, trillions, infinite. It literally does not end. Okay, so at the beginning of the year, I know you remember like it was yesterday, we talked about different classifications of numbers. We talked first about rational numbers, how it included decimals, fractions, all those fun things. Pi technically does not even go into the rational part of numbers because it is not an ending decimal. When we talked about the fractions that went in here, like we said, okay, 0.33333, that's what kind of decimal is that? It's a repeating decimal. And then we also talked about 0.5. Does anyone remember what kind of decimal that is? Terminating decimal. It ends, it stops, okay? 0.625 is a terminating decimal because it stops right there. But with pi, it never ends. So if I try to put it down my funnel, it literally would get kicked out, okay? It's not a rational number, it's called irrational.
Wait, how is it going to
It is irrational because, it is irrational because it goes on forever and we cannot write it as a fraction or a ratio, of 2 integers. Okay, with repeating decimals like 0.3, we know that's equivalent. 0.3 repeating is equivalent to what fraction? 1/3. Again, 1/3 is a ratio of 2 integers. That works. There is no fraction form of pi. There's really close numbers, but we technically cannot write it. The decimal in there, it doesn't repeat ever. Could I do a bar notation on that at all? No, it does have like repeating numbers, but the remainder is always different, so it changes. Okay, so pi is irrational in that it can't be written as a terminating or a repeating decimal. It's a number that goes on forever. Next year, y'all will go into more irrational numbers, but for right now, that's the one that's we use approximations. Pi is often approximated. It's about, okay? In decimal form, we round it to its nearest hundredth a lot of the time, so 3.14. And the closest fraction is 22/7. If you take out your calculators, Miss Otto will do it for her class. But if you do 22 divided by 7, you get really close to it. Okay? If I did 22 divided by 7, I still get that 3.14. Can y'all see that?
Yes.
But then it changes after that. This fraction is the closest that we have, that we use, but the rest of it, right? Okay. So, on your best friend, let's go ahead and get our best friends.
Star chart.
Let's get out our best friends. Okay? Towards the bottom in the additional information part of the star chart, you'll see that pi is on there. And it has the decimal and the fraction form. It says that pi is approximately. Those wavy equal signs means approximately 3.14 or 22/7. Okay? It doesn't mean equal. It's not the straight equal signs. When it's curvy like that, it's about. Approximately. Y'all good with that? Okay. So we're going to move on to calculating circumference. So if I wanted to figure out the circumference and I'm given the diameter of my circle, what do I need to do? If I have the diameter, how many times did the diameter go in there?
3.
Into the circumference? Not 3. Pi. We would take the diameter and multiply it by pi, and that would give us our circumference. Okay? That is the formula that we use. What if Miss Weidel only had the radius though? Instead of the diameter, I had the radius. How many radius did we say was in the diameter? We said there's 2 radii, times pi would also give you the circumference. Okay? And those 2 formulas are written right here. Okay? Where else can we find those formulas? On our best friend. So let's go ahead, take a finger, put it on that formula. A lot of people are going to point to the wrong one, so be careful. Don't be that person. That is not the circumference. We are looking for the circumference formula. Okay? Where do you see it? I'm going to pause and resume the recording. Okay? So when we're calculating circumference, it does not matter which formula we use. I tend to go with what is given to me in the problem. So let's do one together. It says determine the circumference of a circle with a radius of 21, and it tells me to use the fraction form of pi. Okay, so just like area, I'm going to do 3 easy steps. What are those 3 easy steps? SSS. So we're going to start with our formula. Which formula do we think we're going to use in this case? Pi b or 2 pi r? 2 pi r because we're given the radius. Okay, so start with that. Formula 2 pi r. Then I'm going to substitute in my values. C is equal to 2. They said for pi, we're going to use 22/7 times the radius, which is 21. Next, solve. Okay, I like to get rid of my whole numbers. I try to avoid the fractions if I can. That's not a part of the fraction. I already know that. So let's do 2 times 21. That gives me 42 times 22/7. To multiply a fraction by a whole number, I need to put a 1 under it, and then multiply. The reason, though, we use 22/7 sometimes is because we can cross simplify. Can I cross simplify in this case?
Yes.
Yes. With what 2 numbers?
42 and 7.
42 and 7. I can divide them both by 7. 42 becomes 6, and 7 becomes 1. And then I have 1 in my denominator, so it doesn't even matter. 6 times 22, take a second. Nope. 132. Because it's talking about the distance around, my units are just going to be inches. 132 inches. Now again, this is an approximation that pi 22/7, that's not the exact version of pi, but this is pretty close. Okay? And I'm okay with pretty close. Because it's a decimal that goes on forever and I don't care, past 2. Okay? All right, so just a little bit more practice. I'm given a circle and I'm finding the circumference. It says, scale out, and then it says to use 3.14 for pi. Okay, so we're not just going to find the circumference, we're going to find some other parts so we get used to a circle. That 11 inches is talking about the radius because it's halfway across. The diameter, 11 inches, the diameter therefore would be, because it is double, 22 inches. and then I'm going to find the circumference. Now, I'm going to practice using both of them, again, based off of what it gives me in the original problem. In the original problem, it gives me the radius, so the formula that I'm going to use is C is equal to 2pi r. Substituting in my value, C is equal to 2, it says to use 3.14 times the radius of 11. And let's start solving. Again, I'm going to do it in friendly ways first. 2 times 11, that's 2 whole numbers. C is equal to 22 times that 3.14. Take a second to solve that out. Great. Okay, that's the answer. The next problem gives E the diameter of 26 centimeters. Therefore, my radius is going to be 13. Just making sure we're practicing what is what. Okay, and this one, let's go ahead and use which formula?
C equals
Pi d. Let's use the pi d formula since it gave me that. Substitute and solve. All right, what did you go get?
81.64.
81.64. Units are
Centimeters.
centimeters. All right, did we get the flow? We get the gist? Great, awesome. Looking down here though, it's a little bit different. Okay, we're still finding the circumference, but it says to do it in terms of pi. So I want to show you what that means. Okay, we're going to start off the same way. 9 centimeters is talking about the diameter. We're going to find the circumference, so we're going to use C equals pi d. We're trying. We're getting there. Okay, substitute in. So for this one, again, I'm going to leave pi. It doesn't really say which one. It honestly doesn't matter. I'm going to leave pi, but then I'm going to go ahead and put 9 pi, and that's actually all that I do. When you leave it in terms of pi, you don't do the multiplication. Are you still saying that you need to multiply 9 times pi? Yes, okay, because my answer is not just 9. I still have to multiply it. But when you leave it in terms of pi, that means your answer still has pi as a part of the problem. Okay? So I would just leave it there and put the centimeters next to it. This is technically a more accurate value because I haven't used an approximation of pi. I still say I need to multiply it by pi. I didn't use it as an approximation of a decimal or a thing like that. But you'll see either tomorrow or the next day why it's actually helpful to use things in terms of pi. But for right now, that's what it looks like. So let's do another one together. I'm going to go down and let's do 4. 21 is the value of the radius. So let's use C is equal to
2 pi
r. Let's substitute in our value. C is equal to 2. Again, I'm going to leave for pi times 21. Can I go ahead and do the 2 times the 21? Absolutely. C is equal to 42 pi. Okay? Again, I'm going to use that line in there, and that's where I'm going to leave it at. Wow. Okay? Terms of pi are the best kind of problems because you don't have to use fractions or decimals. You just leave it times pi. Okay? So, those kinds of problems, those really aren't too bad. And then you've got some word problems on the back that you will do. But there's some other parts that I need to explain for your homework. Okay? So you need to finish the homework packet for homework, but there's a second part. That paper that I had you do your sketch on, if you flip it back over, you'll see at the top of the paper it says, what kind of pie do you want? Okay? You are going to be watching what we call a flip lesson. We haven't done any this year. But what you're going to do is you're going to watch a quick video. It's actually Mr. C, the science teacher, because he recorded it last year for us. It's him doing a little YouTube video about the different kinds of pi and when it's useful to use each type. Okay? It's not always best to use the decimal or the fraction. Sometimes you'll see that 3 is a better option, but you need to know when that is the appropriate time. So what's going to happen, you need to finish the homework and you need to watch that YouTube video tonight. There's 2 parts and I will be checking those parts tomorrow. Keep in mind, you also might want to work on your test review. Maybe you know how to do some of the circumference problems now, but if I was saying homework, I would probably do the test review tomorrow since there's quite a bit tonight. You'll understand what's happening? Okay? You'll have the rest of the whole,
So are we using the whole rest?
Yes, whole rest. So I would go ahead and get as much done tonight, so you only maybe have to do the YouTube video tonight for homework tonight. It is linked in Canvas for y'all to watch. Okay, y'all have a great night. Thank you and good night.